In this session, we are going to see about the mathematical concept. So, computer science is a practical discipline. So, the mathematical study of the model of the computation is termed as a theoretical computer science. Okay, so there is many logicians, Church, Post, Turing, Klein have made a great contribution towards this theory of computation. Okay, so as the subject deals with the mathematical study, it is necessary to know the fundamental concepts of the mathematics. We want to know the fundamental concept of the mathematics. So we can see the introduction of a formal proof. So proof means it is a convincing argument that some statement is true. So there is different types of proof. That is a deductive proof, then proof by contrapositive, proof by contradiction, proof by cases, then proof by counter example, and inductive proof or proof by mathematical induction. So we will see one by one. So first we will see about the deductive proof or a direct proof. So a deductive proof consists of sequence of statements where truth lead us from some initial statement called the hypothesis to the conclusion statement. Okay, so for example, we can prove this, that is, prove that if x is greater than or equal to 4, then 2x is greater than or equal to x square. So here we are going to prove this. Okay, we are going to prove this. So here it is given x value is greater than or equal to 4. So with this we can try to solve. So when x is equal to 4, okay, when x is equal to 4, then 2 power x is equal to 2 power 4 is equal to 60. Then x square is equal to 4 square. Okay, it is equal to 16. So hence we can write this as 2 power x is equal to x square. Okay, we'll prove that 2 power x is equal to x grow. So when the x value grows larger than the 4, so what will happen? 2x doubles each time when the x value is increases by 1. Okay. Then however x square grows by the ratio. So by the ratio means x plus 1 by the x the whole square. So which cannot be greater than, it cannot be greater than 1.5625. So it is less than the 2. It is less than the 2. So each time x increases above 4, the 2x grows more than the x square. Okay, 2x can grows more than the x square. So hence this particular statement is proved. Hence the particular statement is proved here. The next one, proof by contrapositive. The contrapositive of the statement can be written as if H then C is, if not C then not H. So to prove this statement, it is enough to prove its contrapositive. So here we have taken the example, prove that for any integer I, j and n, if I into j and is equal to n, then either I is less than or equal to root of n or j is less than or equal to root of n. So here the given statement is, if I into j is equal to n, then either I is less than or equal to root of n or j is less than or equal to root of n. So here what is the contrapositive of the statement? So the contrapositive of the statement is the contrapositive of the statement is, if I is greater than root n and j is greater than root n, then I into j is not equal to n. If I is greater than root n and j is greater than root n, then I into j is not equal to n. So here we need to prove the contrapositive statement. Okay, we have to prove the contrapositive statement. So here what is given in the statement? So that is I is greater than root n. So we can consider this as a first equation. The next one, j is greater than root n. So we are taking this as a second equation. So now we have to multiply the first equation by j in both the side. Okay, now both the side we are going to multiply by the j. So what will happen? It is I into j. Okay, I into j, it is greater than root n into j. So we will consider this as a third equation. Then next multiply. Okay, multiply to second equation. We are going to multiply in both the side by root n. We are going to multiply. So what will happen here? It is root n, right? So root n into j is greater than root n. So we can write this root n by the n. So root n into j is greater than n. So this is the fourth equation. So from third and fourth equation, okay, we can write this I into j is greater than n. I into j is greater than n. So hence I into j is not equal to n. So the contrapositive of this given statement is true. Hence the given statement is also true. So this is about the proof of contrapositive. The next one, the proof of contradiction. Proving the statement by contradiction means showing that if it is not true, some contradiction result. Okay. So here we want to prove root 2 is irrational. We have to prove that root 2 is irrational. So to prove this contradiction, we have to assume that the given statement is wrong. Okay, we have to assume that given statement is wrong. So that means we have to assume the root 2 is rational. So assume root 2 is rational. Okay. So any rational number can be written in the form of p divided by q. So here where p and q are integers. So we can write root 2 is equal to m divided by n, where m and n are integer. So now what we are going to do, divide m and n by all the factors common to the both. We simplify root 2 as, that is root 2 is equal to m divided by n. So with the common factor we have to simplify. So but here there is no common factor. So what we are doing, we are writing this as m is equal to root 2n. So we are taking this as a first equation. Therefore here based on this, okay, so what we are doing, we can square on the both the side. So take the square on both the sides of 1. I have to take square on both the sides of the 1. So what will happen? This n square, here root 2, so we can write as a 2n square. Okay, 2n square. So therefore m square is even. So how m square is even? So here we are multiplying the n square by 2. So for example, if n value is 3, so n value is 3 means 3 square. 3 square is 9. So 9 into 2, it is 18, it is even. Otherwise, we can take the n value as a 5. If you are taking n value as a 5, 5 square is 25. 25 into 2, it is even. So, m square is even. Hence, hence m is also even. Okay, m is also even. So, this is the second statement here. So we can write, so m is even, right? So we can write, so we can write m is equal to 2x. We can write m is equal to 2x. Then from the equation 1, so that is, we can write, instead of m, we can write this root of 2n. Root of 2n is equal to 2x. So we have substitute the value of m here. So root 2n is equal to 2x. Then what we are doing, we are squaring both the sides. Squaring both the sides. So when you are squaring this, root 2 into root 2, it is 2. So 2n square, it is equal to 4x square. Okay. So we can write this as n square is equal to 2x square. So therefore here n square is even. Same what we see as a m square. N square is even. Hence n is even. So hence n is even. So this is the third statement. So from 2 and 3, we see that m and n have a common factor 2, right? So here m is also having common factor 2 and n is also having the common factor 2. Okay, so which is a common factor 2, which is a contradiction to our earlier assumption, that is m and n have no common factors. Okay, there is no common factors. Therefore, our assumption that root 2 is rational is wrong. Hence, root 2 is irrational. Okay,